Hey guys, I have a 99 Club Car DS. This is originally a gas golf cart, and I am going to be converting it over to a lithium iron phosphate electric system. So this would actually be great for anyone who's wanting to convert their 36 volt or 48 volt resistor cart. This would be a pretty nice upgrade for a system like that. Well, let's get started. So this golf cart is one that I built. It was a 99 gas golf cart, and I converted it over to a Kohler CH440 engine, had the Kawasaki engine in it. This golf cart had been in Hurricane Katrina, been underwater, and needed a lot of help. Little quick story about it. I've bought a fiberglass body kit, Jeep, you can see that. And I did all the paint work and everything myself. It's not perfect, but it works for us. Put a 6-inch lift kit and put 23-inch tires on it. Kept it basically kind of stock looking on the inside. I made my own little dash panel. And part of my electric conversion, you can see I've got the battery monitor already installed on my dash panel. So just kind of made it my own. It's a pretty unique little setup, but I think it turned out pretty cool. So for my conversion, I chose to go with a 51.2 volt 50 amp hour battery from EcoWorthy. Chose EcoWorthy because it was the only one I could find that was in this size, and it fit really well where the fuel tank used to sit. And I can also come back and add another battery later where the existing battery was to get to 100 amp hours. I bought a used resistor or electric golf cart. I pulled the axle and the motor out of it and sold the golf cart, and really only ended up with about $50 invested in the rear end on this thing, so it's very cheap. And I can always upgrade the motor later. I do have a 12 volt lighting system on here, so with that in mind, I had to get a DC to DC converter to take the 48 volts down to 12 volts. I just went to AutoZone, picked up this little fuse panel so I could actually add a little bit of distribution to my lighting. One goes to reverse lights, one goes to running lights, and there will be another one that runs the signals and horn. I made up a little ground strip so I could tie some grounds in on here, and just bolted out on an aluminum panel and bolted it to the side of the frame. I went ahead and invested in a what I think is a good solenoid 400 amp. Has the resistor and a diode in it, and then I bought a new F&R switch too, so that'll be tied to my reverse lights that I have, and then that'll be my switch that's going to be tied in series with my key switch and throttle. So the controller I chose is a Curtis style DC motor controller. It's I believe 500 amp, and which is more than what I'm going to actually need. I'm not looking to go any kind of real high speeds. If I can get about between 15 and 20 miles an hour, I'll be pretty happy with that. Some of the other components that I got. This is basically the EcoWorthy battery monitor that I chose and installed in the dash panel already. That'll be where the Hall sensor is. That'll pick up the amperage. And then there's another set of wires that'll read the battery voltage. And then there's the PB6 style throttle controls that I'll tie to the existing linkage that came from the gas throttle controls. So I'll have to build a mounting bracket. So that'll probably angle aluminum will work just fine for this. So here's my bracket. I've already laid out the holes, 4 holes on here, and so to match the holes that go into the controller there. One of the problems I'll have is I have brake cables right where I want to mount this. So I went to Lowe's and picked up some hardware, some spacers, and pretty much what I'm going to do is have this mounted just above the brake cable, and then the controller can sit down on top of that. So it should come out pretty clean and give plenty of clearance for the brake cables. So here's where my linkage is coming out from my accelerator pedal. And so basically what I'll do is have a aluminum bracket, and then I will remove this little ball stud, and I'll replace that with a bolt. I've got a hind joint already there, spherical end. That should work just nice with a little 1032 screw. And then this will just be mounted down here with that aluminum angle bracket. So guys, got the controller mounting plate completed. It turned out really nice. It's a shame that most of it gets covered up, but anyway, I had a little bit of clearance issue right there, and so I ended up having to put some washers up under here just to kind of pick it up a little bit. But other than that, yeah, it turned out good. Hey guys, if you like what you've been watching so far, make sure you hit that like button and subscribe for future updates. I intend to share a little bit more about how I got to where I am now. So my throttle switch is going to go somewhere in this neighborhood. I'm probably going to use the second hole. I'll have to decide that later. Probably position it somewhere in this, kind of like that. So as the linkage travels back and forth, right there. So that should give me plenty of throw on it. Okay guys, I didn't bore you with drilling all the holes and layout, but there's the 2 holes, and here's the bracket that I made for the PP6 switch here, throttle control. So I just showing you how the bolts are here. This is extremely rigid. Really all the forces are going to be pushing back this way, so there shouldn't be any problem with stability on this bracket. So we'll go ahead and start assembling it. One of the things I did want to point out, I did end up using the second hole up, mainly because my accelerator throttle rod right here was going to rub against the frame. So that actually worked out a little better, and I should have more than enough travel. Yeah. So, oops. Let's just stick a little nut on here. Yeah, we'll just kind of hold that in place anyway for now. And we'll stick the screw in here. All right, guys, there it is. And that is extremely rigid, and I turned it on an angle so it would be in line with the accelerator rod right there, so you can hear the relay, I call it limit switch, I apologize. You can hear the limit switch as soon as I press the accelerator, so we get off of that and travel, and that looks pretty good. So let's see if we check our ohms. All right, let's take a look at what our ohm meter shows. And so we're at 0 here. We're just off at a limit switch, and we're traveling. It's a good bit of travel. So I don't think we're gonna have enough to make it all the way to 5. Uh, 4.1, that's max on it. So I'd like to get it all the way to 5K, so we may have to do some adjustments on the lever. All right, guys, we've got our electrical installed. We have our PV6 throttle switch. Some people call it a pop box. So that's installed. And we have our motor controller, the battery's in place. Next thing we gotta do is just wiring. So here's the wiring schematic out of the installation manual for the Curtis motor controller. So this is where you can see where we tied in our pop box to J2 and J3. I'll show you that on the golf cart later. And then this is the schematic up here for wiring in the F&R switch to the controller and the battery. So that'll be all the heavy gauge wiring. So one of the things I did is just kind of drew it out kind of in my own words. So just make sure that I really fully understand the function of each wire and how it's routed. So here's where you'll see that J2 and J3 are tied in to the limit switch off of our pop box. And then you'll see where our battery cable is going to come over and come into the contactor. And then the contactor will then go down to B+ on the motor controller. And then also there will be another wire that'll go from the B+ over to the motor. And these are the limit switch for the pop box. These will be the wires that are coming from the key switch here. And then these will be going to the lighting in the low voltage from here from our terminal blocks. So this is where we'll also tie in the 48 volts that'll come from the key switch to power up our DC to DC converter. And then we'll have our 12 volts out and to run all the other lighting and horn. So this limit switch up here is for the reverse lights. So whenever we switch to reverse, this will power up the backup lights. And then this will be the other terminal will come from the F&R switch. So this enables forward and reverse, and that'll allow you to pull in the contactor. Okay guys, this is just what I come up with for my own little wiring schematic, where I have the battery here, and then the positive will come through the key switch, which will come through and then power up the DC to DC converter, and that'll get me down to my 12 volts. And then the 48 volts will then go through the F&R switch, and then through our throttle switch, and then enable our contactor. And where the 12 volt DC will come down here and go through my fuse block and go down to my horn and signals, my running lights, and my reverse lights. And then also the positive negative will come off of the battery, go straight up to the battery monitor. All right guys, it is done. Man, this thing is finished up. I'm going to show you a little bit about what I did with some of my wiring, kind of make it clear for any type of future service. So I labeled all my wires so I know exactly where they needed to connect, and then you can see how everything's identified here. So I only had a couple of issues when I first hooked everything up. First thing is that it didn't work. I powered everything up and went to mash the pedal and nothing. Then I figured out that this little guy right here, this goes to J1, and that one I tied to my key switch connection that comes off of the dash. So this will, as soon as I turn the key on, this wire has 48 volts. And so I had to enable the controller before it would work. So I got that done, and then it started working. Then problem 2 came up. It was running backwards. So then I swapped my S1 and S2 cables and to get the rotation running correctly. Other than that, it's the only issues I ran into. All right, let's go ahead and try our forward like that. And let's test out our pedal. Here we go, we're all lit up. And so it's reading the voltage there, and amperage is showing backwards. I remember they said something about that. So what that means is I've got to flip the hall sensor around. Okay. So you know what, guys, I went back to read the instructions again, and it looks like everything's correct. That amperage number should be negative when the battery is discharging. So that was correct. And if I hook up a charger on it, then it should go positive. So I don't need to do anything. Everything looks correct. So this is my updated drawing, and you can see where I just noted on here that I swapped these and corrected that across S1, S2 to get the rotation correct, and then added the key switch to J1 to enable the controller. All right, guys, we got this budget build done, and it's time to test this thing out. So let's get to it. Wow, that solenoid's pretty loud. Backs up pretty good. All right. Okay, I set up my little GPS app on my other phone there. So we're gonna see how well this thing cruises. Keep in mind, I was just wanting to get about 15 to 20 miles an hour. Yeah, I'm pretty happy with this. That is pretty awesome. We live in a pretty hilly neighborhood, so it pulls this hill really well. It would be awesome if it repaved the road, though. All right, that's to the floor and doing 17 coming up the hill, 16. All right, flattens out. Getting pretty close to level here. The other was downhill. This is 18 and a half. Yeah, super pleased with this. It's met all my expectations. Yeah, it's a stock motor too, and I don't see any reason to change it. So guys, I put together a little spreadsheet to kind of show what my real cost was for this project, and I believe it was truly a budget build. I came out pretty good because when I bought the 93 electric golf cart, I was able to sell it for $200, so I only ended up with $50 in my axle and my motor. And came out really lucky on that because the motor seems to be in really good shape. And also the existing axle assembly and engine I pulled out, I was able to sell it for $650, and that really offset a lot of my costs there. But this is certainly a great conversion right here. I think you'd be pretty hard pressed to get into a lithium setup for this kind of money. And if you're wanting to do a resistor cart conversion, I kind of threw these numbers together. This is probably, I don't know, sometimes the DC motor controller, that price varies, maybe 140, 150, but not much. And you may want to get some type of little fuse block and miscellaneous hardware, add that cost into it. You still come out pretty good at right around $1,000 to get into a lithium conversion and to upgrade all of your controllers. I mean, basically everything would be like brand new, and definitely I think would be worthwhile doing. So if you're looking to consider getting away from those resistor coils and cleaning up your wiring and getting more updated components, I think this would be the way to go. Hey guys, thanks for watching my video. I hope you found it helpful. If you don't mind, just like and subscribe and share your comments. And we'll see you next time.